Hello and welcome to Otten Math. In this edition of Otten Math, we're going to talk about graphing and writing equations of hyperbolas. So specifically, we're going to talk about characteristics of hyperbolas, graphing hyperbolas, writing equations of hyperbolas, and then taking hyperbolas in general conic form and then moving them into standard form. So let's talk about the definition of a hyperbola. So hyperbola is a set of all points such that the difference of the distances between all points in the foci is constant. So with an ellipse, remember we said that the sum of the distances is going to be constant. So with a hyperbola, the differences are going to be constant. So d1 minus d2 is equal to, in this case, d2 minus d1. So the distances from the focus 1 to the hyperbola branch on the right minus the distance from focus number 2 to the hyperbola is going to be the same as the difference between the focus 2 to the second branch on the left minus the focus 1, the distance of the branch on the left. So the difference of the distances from the foci to the hyperbola branches are going to be constant. That's the definition of a hyperbola. All right, so let's talk about some of the things that you need to know about a hyperbola. The first is we have a transverse axis that runs through the foci, the vertices, and the center. So this is different than the ellipse. The ellipse had a major axis and a minor axis. The hyperbola just has a transverse axis, and the focus, the foci, the vertices, and the center all lie on the transverse axis. The vertex or the vertices lie A units from the center along the transverse axis. So vertices are minus A and then plus A units along the transverse axis from the center. So that's similar to an ellipse. But again, with an ellipse, of course, you're working with a major axis. There is the center. So the center of the hyperbola is the midpoint between the vertices and also the foci. So if you know the value, the coordinates of the foci or the vertices, you should be able to figure out the coordinates for the center. All right, the C value, so now we're back to the same ABC values that we had with the ellipse. The C value, again, is the distance from the center to the foci along the transverse axis in both directions. So I have C units to the left and C units to the right of the center gives me the location for the foci. And there are two of them. So remember from our discussion on ellipses, the formula for C squared was C squared is equal to A squared minus B squared. But for a hyperbola, it's C squared is equal to A squared plus B squared. So there's a difference in the formula for C squared between a hyperbola and an ellipse. For a hyperbola, it's C squared is equal to A squared plus B squared. For an ellipse, it's C squared is equal to A squared minus B squared. All right, asymptotes are the lines which the hyperbola come close to but never touch. They form the framework for the branches. Here's a branch of the hyperbola, branch 1 and branch 2. And the branches get closer and closer to the asymptotes, but they do not touch the asymptotes. All right, so we're going to talk about the B value. The B value still exists, but there are no co-vertices. We're going to use the B value to figure out the slope of the asymptotes. And in the case where I have a transverse axis that is horizontal, the slope of my asymptotes is going to be plus B over A and minus B over A. So the two slopes are plus or minus B over A. And then I can figure out what the equation is of the asymptotes by taking a point, which is the point of intersection of the two asymptotes, which happens to be the center of the hyperbola, and then the slope. So I use point slope form to figure out the equation for the two asymptotes. All right, so here we go. I got the asymptotes, center, and these red lines really need to be moved so that they cross at the center. So the asymptotes cross or intersect at the center. Transverse axis, the two foci, two branches, and the two vertices all comprise the hyperbola. So here's a quick quiz. Provide the sum of A, B, C, D, and E. You can pause for a moment while you quiz yourself on this. All right, so A is going to be a focus. Whoop. Well, I'll just go back and give you the answer. A is going to be the focus. B is a branch. C is also a branch. D is going to be a vertex. And E is going to be the center. Second, provide the sum of F, G, H, and I. I is going to be the asymptote. I'm going in reverse order. G, there's no meaning, right? There's no longer a minor axis. We just have the transverse axis. F is going to be the transverse axis. And I think we got all of those in there. Okay? All right, so let's move on. So now we're going to graph hyperbolas. All right, so the formula for a hyperbola of the horizontal transverse axis, x minus h squared over a squared minus y minus k squared over b squared is equal to 1. So notice the center of the hyperbola is located at hk, just like we had the center of the ellipse at hk. And so now the only thing that is different is that we have a negative sign here instead of a positive sign. So with the ellipse, we figured out what the major axis was, the orientation of the major axis, by finding the largest value for a squared. Now a squared is going to be the denominator that's associated with a positive term. So a squared could be less than b squared. It could be greater than b squared. It doesn't matter. All right, so when we're looking at the transverse axis, we know that, horizontal transverse axis, we know that the a squared value is going to be underneath the positive term. In this term or case, the term that's positive is the x squared term. Right, so you can also have a vertical transverse axis, and in this case, the a squared value underneath the positive term, which is the y squared value. So hk is still the same. It's still the center of the ellipse. H is still associated with x. K is still associated with y. B is still b. A is still a. But the a squared value no longer, relative to the ellipse, is no longer the largest value. It's the value in the denominator that's associated with the positive term. All right, so again, A is the distance from the center to the vertices along the transverse axis. A is the denominator associated with the positive term. C is the distance from the center in both directions to the foci along the transverse axis. C squared is now equal to A squared plus B squared. Not C squared is equal to A squared minus B squared. C squared is equal to A squared minus B squared with an ellipse. B is the denominator associated with the negative term. It's going to help you find the location of the asymptotes and the slope of the asymptotes. We said that with a horizontal transverse axis, the slope of the asymptotes is plus or minus b over a. You still need to get the point at the center. Let's put that in there. For the point slope formula to create the equation of two lines for the two asymptotes. All right, so when you have a vertical transverse axis, the slope of the asymptotes is now a over b. So you can see b over a with a horizontal transverse axis, a over b with a vertical transverse axis. So you have to make that transition when you're evaluating the two different orientations for the transverse axis and the hyperbolas. All right, so now we're going to graph hyperbolas. I want you to graph this particular hyperbola, and I'm going to pause here, and then we're going to come back and go through the answer. All right, so the first thing we're going to do is we're going to write the equation in standard form, which it's written. We're going to identify the orientation. We see that the positive term is the x squared value, so it's going to be a horizontal transverse axis. My a squared value is 7 squared. My center is 3, 2. So we're going to plot 3, 2 here. Here's my transverse axis. All right, so now we're going to find the a, b, and c values. We said the a value is 7. So we're going to move 7 units to the right and 7 units to the left to find the coordinates for the vertices, negative 4, 2, and 10, 2. And we're going to find the equation for the b value. The b value is 4. So I know that in the case of a horizontal transverse axis, my slope is plus or minus 4 over 7. I use my point slope formula. Y minus 2 is equal to plus or minus 4/7 times x minus 3. So those are my asymptotes. And then I find out the focus. The focus is going to be a squared plus b squared. A squared is 49. B squared is 16. 49 plus 16 is 65. The square root of 65 then is my value for C. So I can figure out the foci by moving along the transverse axis from the center plus or minus root 65 units, which is a little more than 8. So 3 plus or minus root 65, comma 2 are the coordinates for my foci, and you can leave this here as the coordinates for both as one set of coordinates in one parentheses using plus or minus. That's fine for me. All right, and then we're going to graph the hyperbola, drawing the using the asymptotes and the foci and the vertices. All right, so there's our graphed hyperbola. Okay, so the next thing that we're going to do is we are going to write an equation of an ellipse, given some information. There are a lot of words here that you can copy down. You can copy them down if you want. I'm going to move forward after I pause for a moment. All right, so we're given this graph of a hyperbola, and now we're going to figure out the equation. So we see that it's a, and you can do this on your own and pause this. You can see it's a vertically oriented transverse axis, so the branches open up and down. My center is negative 3, 2. I have a vertex of negative 3, 0, and then one focus of negative 3, 6. So those are the values that we have to work with. So we first are going to establish the coordinates for the center. It's going to be negative 3, 2, so I'm going to write, and I know it's vertically oriented, so y minus 2 squared minus x plus 3 squared. Now I have to figure out the value for a. So I know the value for a is the distance from the center to the vertex along the transverse axis. I have negative 3, 2 to negative 3, 0 leaves me with 2 units. 2 units squared leaves me the value for a squared, which is 4. And now I also know the distance from the center to the foci is going to be the c value. Negative 3, 2 to negative 3, 6 is going to be 4 units. 4 units squared is 16. So 4 squared, c squared, is equal to 2 squared, or a squared, plus b squared, which we don't know yet. So 16 minus 4 leaves me with 12. So b squared is equal to 12. So now I can place the value for b squared underneath the negative term in my equation for my hyperbola. And that's it. I've just written an equation for a hyperbola. So first I had the center. I found the a value. I found the c value. I used the a and c value to find the b value. I placed the values in their respective location. A squared, of course, b squared. I made sure that the orientation as vertical provided me with a positive term for the y squared value. Okay, last thing we want to do is we want to take the general conic form and convert it to standard form by completing the square. So here's standard form again. Remember the difference here is minus, and general conic form here, difference here is a negative value. You can see pretty quickly if this were a plus y squared, then it will either be an ellipse or it will be a circle. But when it's negative y squared, for at least the values that I give to you in the conic section, you know if we have 2 squared values, it's going to be a hyperbola. All right, so let's take a general conic form for a hyperbola and let's rewrite it into standard form. So the first thing we want to do is we want to group the terms with x and y, which we're going to do, and we're going to move the constant to the right-hand side of the equation. Then we're going to find the greatest common factor in the terms. So I'm going to separate 64 and negative 9 here. Be careful here, negative 9. We have to change this sign to a plus 4. So be careful in the transition that you distribute properly and properly place the signs and the values. And then we're going to complete the square here. I complete the square on the left-hand side, plus 4. And when I do that, I'm adding plus 256 on the right-hand side, 4 times 64. And I'm subtracting 36 on the right-hand side, plus 4 times negative 9. That leaves me with an equation that looks like this, 64 times x plus 2 squared, which I've just rewritten as a binomial. You can see I've gone from a trinomial here to a binomial, and then I've added the values here on the right. So I've made that step to rewrite perfect squared as binomials and simplify the right-hand side. And now I'm going to divide. Remember, we want this right-hand side to be equal to 1, so I'm going to divide both the right and left-hand side by 576. And then we're going to simplify from there. And we end up with x plus 2 squared over 9 minus y plus 2 squared over 64 is equal to 1. And we did all that in less than 15 minutes. That's it for this edition of Math. Please join us when we talk about next time on 6.5 when we graph and write equations for parabolas.